So we're looking here at graphing trigonometric functions, and we're going to be analyzing the graphs of y equals sine of x and y equals cos of x. And we have a huge problem here, because when we graph things, we talk about x and y coordinates. So when I talk about the graph of y equals sine of x, I'm going to have a graph where I plot y equals sine of x on the vertical axis and x on the horizontal axis. But really, you need to really try to focus on something that's important here. The x and y on these graphs are not the x and y on the unit circle. It's confusing. The y on the unit circle for y equals sine x does happen to be the y on this graph, because on the unit circle, sine of a rotation angle is y. But on y equals cos x, the graph of y equals cos x, the y coordinate on this graph, get ready for this, the y coordinate on this graph in the upper right corner is the x coordinate on the unit circle, because the y coordinate on this graph is cosine of an angle. And cosine of an angle is an x coordinate on the unit circle. By the way, both of these x coordinates on these graphs have nothing to do with x and y on the unit circle. They're the rotation angle that takes you to a place. So you have to be very cautious about what everything means here. We're going to be looking at the transformations of y equals sine of x and cos of x, and also looking at the graphs of the three primary trig functions, which would be sine, cosine, and tangent. So I'm just going to give you in your notes what the graph of y equals sine of x looks like. And we can certainly explain this graph based on the unit circle. So I'm going to draw a little circle up here. You don't need to draw this. And I'm going to put my axes in. And I will put a terminal arm in. And that terminal arm right now is showing a rotation angle of 0 radians. And if you look at the point where that intersects the unit circle, that point has a y coordinate of 0. In other words, when an angle is 0 degrees or 0 radians, the sine is 0. What that means is there's a point here. If you look at what happens to the y coordinate on the unit circle when I increase the angle, the y coordinate goes up. Now, on the unit circle, the y coordinate is the sine of the angle, which means as this angle increases, as this angle x, which is really theta, increases, the y coordinate, which is sine, goes up. And what happens is, when you finally get to pi over 2, the sine of pi over 2 is 1. And that's why when theta is pi over 2, the sine of theta is 1. And we continue to rotate around to show you what this thing is going to look like. So for example, I'm just going to have to move everything. Give me 1 second. For example, when you're at around 150 degrees, you can see the y coordinate on the unit circle, which is the sine, is getting to be close to about a half. And then eventually, when you're at 180, which is pi, the y coordinate is back at 0. And that's why we have a point. I'm not going to do this for every single graph, but that's why we have a point here. Eventually, what happens, of course, is at 270 degrees, or 3 pi over 2, the y coordinate, which is sine, is -1. And that's why we have a point that's here. And then eventually it goes back to the beginning. Once we're at 2 pi radians, or 360 degrees, there's the point of intersection on the unit circle. The y coordinate, which is the sine, is 0. And I want to impress on you that we can go forward and backward any number of rotations, and that's why this graph is going to just continue to repeat in both directions. So this is what the graph of y equals sine of x looks like. I want to impress on you one other thing before we look at the properties of it. When you look at drawing these, look at each wave as 4 pieces. So if you watch your screen and listen at the same time, there is a piece that is up, there's another piece that then goes down, there's a third piece that goes down, and then a fourth piece that goes up. These waves occur with 4 pieces to them. So this thing is identical to this thing. Up, down, down, up. And it keeps repeating. If I wanted to, and I'm not going to change the zoom setting here to show this to you, but if I wanted to, I could take this thing and put it over here, and there's another piece that continues. I could take it and put it over here, and there's another piece that continues. So this thing extends back and forth, up and down, back and forth, to the left and the right forever. So now let's talk about the properties. What are the domain and range? Well, you can see on the graph that that x is any real number. And when I go back to the graph, you can draw this in if you like, but what I'm drawing in is not actually part of the graph. It's just part of what I'm explaining to you. This graph peaks at 1 and it valleys at -1. The graph actually does have y coordinates of 1 in places, and it actually has y coordinates of -1 in places, but it doesn't have y coordinates outside of that range. It's everything from -1 and including -1 up to and including +1. So the range is -1 is less than or equal to y, which is less than or equal to 1. Aaron, was it you that I was having a conversation with about this on Thursday with cosine?
Yes.
Okay, so this is an explanation as to why sine of an angle cannot have a value like -2 or +8. Sine of an angle has to have a value between or equal to -1 and 1. What are the intercepts of the graph? Well, there's a y-intercept equal to 0, and there are an infinite number of x-intercepts. There's an x-intercept at 0, at pi, at 2 pi, at -pi, -2 pi, -3 pi, +3 pi. So what we should probably write for the x-intercepts is the x-intercepts can be described by saying n pi, where n is an integer. And if we had a graph that was in degrees, then we would have said 180n, where n is an integer. What are the maximum and minimum values? Well, the maximum value of the function, a function is y, so the maximum value of y is 1. The minimum value is -1. Now, we have a definition. We have some definitions here dealing with these graphs. One of them is the period. And we give this, this is stupid, I know. The parameter we use for period is k, which is the same as the parameter for a vertical translation in terms of transformations. But we just have to deal with it. K has a different meaning depending on the context. The period of a trigonometric function that's periodic, that repeats, is the horizontal domain over which it repeats. So this is why I wanted to impress on you the fact that this is one complete cycle. That this, whoops, I don't want to do that, that this is one complete cycle. So what is the horizontal distance for that? I guess I'll use a highlighter. It's not showing up very well on my monitor. What is the horizontal distance from here to here? Well, a horizontal distance would be this. And you can see that it's 2 pi. So over a horizontal distance of 2 pi, the thing has a complete cycle. This is a horizontal distance of 2 pi. Now I'm really going to mess this diagram up for you, but I got lots of colors. I told you that a complete wave was 4 pieces. So if you look up here, well, look at your monitor, here is 1, here is 2, here is 3, and here is 4. What is this horizontal distance? What is that horizontal distance? Well, it's still 2 pi. That distance of 2 pi is 2 pi whether it's 2 pi from pink end to pink end, or blue end to blue end, or red end to red end. 4 pieces is 1 cycle, and it happens over 2 pi. So the period is 2 pi. I should know this, but it's been a weird semester. Can you type yes if you've taken Physics 20? Okay, a lot of yeses and a couple of yes, sort ofs, kind ofs-ish kind of yeses. In Physics 20, the period of a wave is the same as the period of this graph. And in Physics 20, the amplitude of a wave is the same as the amplitude of what we're talking about here. So this says, this next point, the amplitude of a periodic function is the vertical distance from the middle of the graph to either the maximum or the minimum. And it is a distance. So now I'm really going to mess this up. Here's the middle of the graph. This is the middle of the graph. I call it the equilibrium position. This is a maximum point. This is a maximum point. This is a minimum point. This is a minimum point. The amplitude is the distance. Well, that's pretty cool. The amplitude is the distance from the maximum to the middle, or from the minimum to the middle. And there's no direction with amplitude, it's a distance. You can see that it's 1 unit between the middle of the graph and the top, or 1 unit between the middle of the graph and the bottom, which means the amplitude, and we have the symbol capital A for amplitude, is 1. All right, now let's talk about the graph of y equals cosine x. I don't want to spend a lot of time doing this, but if I were to draw the unit circle, remember cosine is the x coordinate on the unit circle, so when we have no rotation angle, the x coordinate on the unit circle is 1, which means that when the angle is 0, the cosine is 1. And what we discover, and you could make a table of values if you like as well, is that as the rotation angle gets larger, and maybe I should draw this with the circle. So I'm going to put the circle again. As this arm rotates, creating a larger rotation angle, the x coordinate, which is cosine on the unit circle, gets smaller. So what happens is, as the angle gets bigger, the cosine gets smaller. And then what happens is, as soon as you hit pi over 2, the cosine is 0 because the x coordinate on the unit circle is 0. And then the x coordinate becomes negative until it reaches negative 1. So the cosine of the angle is 0, and then it becomes -1, and then it goes back to 0, and then it becomes +1. Notice there are 1, 2, 3, 4 pieces, and that is considered a complete cycle of cosine. And just like the other graph, sine of x, this thing will repeat. Down, down, up, up. That thing will repeat an infinite number of times in both directions. So on top of this, what I'm going to do is draw sine of x. Please don't draw it on yours. But if I were to graph sine of x, let's do something different. Creative. Sure. I don't know. We'll try that. Sine of x starts here. Sine of x starts here, and it goes up and hits 1, and then it goes down and hits 0, and it goes down and hits -1, and then it goes up at 2 pi back to 0. But that shape that I have drawn is identical to the shape of cosine. The only difference between these graphs is a horizontal displacement. Let's answer the questions now about this domain and range. Well, the domain and range here are going to be the same as they were for y equals sine x. X is going to be any real number, and -1 is less than or equal to y, which is less than or equal to 1. What are the intercepts? Let's talk about the y-intercept first. The y-intercept is 1. And I want to go back and look at the graph with you and throw something else out there that's just going to float around your head for a little while until we need it. Usually when we draw these graphs, so I've gotten rid of everything here. Usually when we draw them, we start when x is 0. So with sine, I start here and I go up, down, down, up. This is called the start point. With cosine of x, when we draw it, it's going to be to our advantage to typically start drawing it when x is 0. But when x is 0, we're at the y-intercept, so this is where we start drawing it, and it goes down, down, up, up. This is called the start point. This concept of a start point is going to be helpful for you later. And the start point is the y-intercept. Okay, so getting back now to the properties of cos, the y-intercept is 1. The x-intercepts are a little trickier. These x-intercepts, this one, and this one, and this one, and this one, are all pi apart. I want you to let that sink in. If I look at the distance that is pi, that's pi horizontally, on the horizontal axis, that is always the distance between the x-intercepts. So what we can do is we can say that the first x-intercept is here, which is at pi over 2. Plus multiples of pi, where n is an integer. And you might say to yourself, if you go back and look at the x-intercepts of sine, there's no pi over 2 there. We just said n pi. The reason we could get away with that was a y-intercept for sine was 0, so we didn't need to write 0 plus multiples of pi. Maximum and minimum values, well, It's the same thing we had before with sine. This graph peaks at 1 and it valleys at -1. So y min is -1, y max is 1. And now we can talk about the amplitude and the period. The amplitude and period are going to be the same as they were for sine. The amplitude is going to be 1, the period is going to be 2 pi. Basically, because a full revolution on the unit circle is 2 pi, as soon as you go through a full revolution on the unit circle, the values of sine or cosine will then repeat. They will be the same as they were last time you were at that position. Visually, this is the period because there is 1, 2, 3, 4 parts giving you a complete cycle. And the amplitude is the distance from the middle to the top or the middle to the bottom. And that covers it for sine and cosine. So I'm going to pause there. Let's do a quick check, please, of too fast, too slow, just right. It'll only take a second because we have a long road to walk down today with this, and I want to make sure you've got a good foundation. Again, I'll remind you, I expect nothing but honesty from you. My feelings are never hurt, so if I'm going too fast, I need to know. Okay, we're okay. So now, let's skip over tangent, all right? Let's not worry about tangent, okay? We'll talk about that later. All you're expected to know about the tangent graph is what it looks like, and we will handle that later. But what you're expected to know about sine and cosine is what any sine-cosine graph looks like. So for example, and you, please don't write this down, you need to be able to tell me the domain and range and everything about this graph. Which includes all kinds of transformations of the graph of sine of x. And that's what the remainder of this lesson is dealing with, and that's all we're doing today. So, use your knowledge of transformations to sketch the following graphs. And it starts off pretty easy, really. It's pretty tame. What does the graph of y equals 2 cos x look like? So we're going to start off with this assumption, everybody. I'm assuming that everybody knows what y equals cos x looks like. I'm going to draw cos x in blue. So what I'm going to draw is y equals cos x. Once you see it drawn, you can write y equals cos x beside it. Cos x starts at 1. And I'm going to take a point here, and I'm just going to move it as if I'm pointing. This is my finger. If you were in class and we were together, I would be pointing in these places. So it has to go down, down, up, up, but we know it repeats every 2 pi. So when we sketch y equals cos x, which is not what this question is, we visually split. I guess I have to get out of here. We visually split this horizontal distance up into, I'll use a, sorry, it's interesting the things you don't think that you're going to have to think about when you're not in, when I'm not with the students. I'll do it this way. We're going to split the distance from here, the distance from here to here into 4 equal pieces. Because we know cosine has 4 pieces. So halfway in the middle takes us here, halfway between those two, halfway between those two. So now we can start to draw this. when we get to a quarter of the way through, this thing will be at 0. When we get another quarter of the way through, it will be down at -1. The third quarter takes us back to 0 and then up to +1. And when you sketch this, you sketch it in 4 pieces in a curvy fashion. We curve, 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 curve. And if we wanted to, we could extend it in the opposite direction. Every time I move a quarter of the way, it goes from being 1 to -1 to, 1 to 0 to -1 to 0 to +1. So this is what the other piece would look like on the other side. And if you wanted to be very fancy, you would put arrows on the end because that's what it does. So when we look at y equals 2 cos x, we are multiplying the entire function by 2, and that tells us that the a value in terms of transformations is 2. So every point is going to be stretched vertically by a factor of 2. And now comes something that I would like you to get in the habit of thinking and doing. Rather than thinking of transformations as stretches here, think this way. When it was cos x, the maximum was 1 and the minimum was -1. If everything is stretched vertically by a factor of 2, if everything is stretched vertically by a factor of 2, come on, then the maximum will be twice as great, the minimum will be twice as great, but the x-intercepts will stay the same. In other words, everybody, cosine normally starts at 1. Here's the start point. Here is, why can't I do that? Sorry, give me a second. Here is the start point of cosine. But since we've been stretched vertically by a factor of 2, the start point is up twice as high. It's still going to go down to the middle in a quarter, down to the bottom in the next quarter, up to the middle in the next quarter, and up to the top in the last quarter. All this number in front does is create a bigger maximum and a bigger minimum. And if you wanted to, you could certainly put in another cycle on the other side. Don't worry if your graph doesn't look nice and smooth. If it looks all pointy, that's okay. So that's what the graph looks like. Now, whoops. Now we have some information to fill in. What's the domain? Well, why would the domain change? I want everybody to think carefully about that, you know what? It doesn't matter what we do to this graph, as long as we don't take the square root of it or something weird. In terms of transformations, the domain will stay the same. What's the range? We can see it's now -2 to 2. The amplitude is 2, and the period is still 2 pi. It still repeats every 2 pi. And that shouldn't be a surprise, because if the period is a horizontal measurement, it's not going to be affected by a vertical stretch. By the way, this here, this 2, and this 2 are all 2's because A is 2. Does anybody have any questions with question 2A? All right, let's try the next one. And by the way, you could graph these on your graphing calculator, but I want to avoid doing that. I hope it's no surprise. I'm not going to graph sine x this time. Well, maybe I'd better. Sine x, I guess I better, starts at the origin and repeats every 2 pi, which means it has to go up, then down to this point, and then down, then up to the next. And it peaks at 1 and valleys at -1. This is sine. Now we have -3 sine of x, which means A is negative 3. Now what that is going to do is it's going to make the maximum occur at 3 and the minimum occur at negative 3. Things are going to be stretched vertically by a factor of 3. The origin, so what I'm going to draw in green will be the new graph. The origin will not be affected by a stretch or by a reflection. Neither will this point or this point. If that 3 in the question were not negative, then it would start at the origin and go up. But because it's negative, it reflects that process, which means it's going to start at the origin and go down to its lowest point, and then back up to the middle, and then up to its highest point and back down to the middle. So this is what y equals negative 3 sine of x looks like. You don't have to draw in another cycle. I just feel as though if I don't, it may not look right to some people. So the green graph is the answer to the question in terms of the graph. Now, what about all this stuff? Domain is any real number. Range is negative 3 is less than or equal to y, which is less than or equal to 3. The amplitude is 3. The period is 2 pi. Does anybody have, I'll give you a second to write that down and think. Does anybody have any questions with any of those? Okay, trying to set you up for success later, I want to point something out to you. If you say the amplitude is A, and the amplitude is always a positive number, if little a is negative 3, which it was in this case, the amplitude is 3. If the amplitude is A, the range will always be that. Always is a horrible word in math. It will always be that unless we shift this thing up or down. Because if we shift it up, those dotted lines, which show the minimum and maximum, are going to move with the whole graph. By the way, the amplitude, I'm giving you a lot to think about here, is always the absolute value of the parameter little a. If little a is 10, the amplitude will be 10. If little a is negative 10, the amplitude will be 10. Let's try another one. Negative 3/5 cos x plus 1. Okay, so I'm going to start off by sketching in cos x. And you know, if you have pencil crayons and felts in different colors, that's ideal, but you don't need to do this. I'm going to graph y equals cos x, ooh, that's thick, in blue. Because I need to remind you what it looks like. Cos x starts at the top at 1. It goes down, down, up, up over 2 pi, and then it's back at 1, which means it's going to hit the bottom here. It's going to hit the x-axis halfway in between and halfway in between. So y equals cos x looks like this. And again, don't beat yourself up if your graphs are a little wobbly. Doesn't matter. That's y equals cos x. Even mine, I'm not really happy with it. It doesn't look quite right, but that's okay. Sometimes it doesn't look right because I've plotted the points wrong. I was just checking it's fine. So now here's the idea. Since a in the function is negative 3 over 5, we know there's a vertical reflection and there's a vertical stretch by a factor of 3/5. What that means is that the maximum, which was at 1, and the minimum, which was at negative 1, are now going to flip because of the reflection. but that means the maximum and minimum will be the same numbers. The minimum of -1 becomes the maximum of 1. The negative doesn't affect these lines. But each of these lines now is stretched vertically by a factor of 3/5, which means that rather than it's starting at 1, it's going to start at 3/5. Everything is stretched vertically by that factor. The minimum is going to be, oh, for crying out loud. The minimum, instead of being at -1, it's going to be at -3/5. So if I were to sketch this -3/5 cos x, and I'm not talking yet about this +1 at the end, okay? I'm going to show you how we can do it all in one shot. So maybe what you should do is just stop writing for a few minutes here. So if I were to sketch y equals -3/5 cos x, what I would do is say that cosine normally starts at the top going down. But since I've reflected things, it starts at the bottom going up. And I would say it would have to go up, up, down, down over 2 pi, which would mean it has to go up to this point, up to this point, down to this point, and down to this point. I want to repeat everything I've said to give you a chance to mentally digest that. This has nothing to do with the +1 at the end here, okay? Nothing at all whatsoever to do with this yet. What we said was that cosine starts at 1 and goes down to -1. Since there's a vertical stretch by a factor of 3/5, it's going to start at 3/5 and go down to -3/5. But since there's a reflection, it starts at -3/5, which is here, and does the opposite. It goes up, and then it has to continue up, down, and down. So does anybody have any questions about that? That's not the answer to the question, because we still have to shift it up 1. Okay, so now here's what we do instead. We don't draw this red thing. This red thing is a waste of our time. What I do is the following, and this is going to seem very weird. After the vertical stretch and reflection, I get those two guidelines. I'm going to call this a guideline. There's a guideline there. There's a guideline here. I don't care what I draw in between those two guidelines. The fact that we have +1 at the end means k is 1, so we shift 1 unit up. I hope that this is something that is not even anything you need to think about. If k is 1, it shifts up 1. So what we are going to do is this. And it's cheating, but it works. I'm going to take this max and shift it up 1. And I'm going to take the min and shift it up 1. Now 1 is 5 squares. So now I've shifted the whole thing up, and now I can draw it. And here's how I draw it. And it's going to require a lot of thought for some of you. You're going to have to think about this later. Cosine normally starts at the top. This is the top now. And it goes through one complete cycle back to the top, which means cosine would go down, down, up, up. Except because of the negative, it starts at the bottom. It has to start at the bottom going up, returning to the bottom into pi. So we split this up into 4 equal pieces. And those 4 chunks occur, here's the middle, the 4 chunks occur by going up to the middle, up to the max, down to the middle, down to the max. So we cheated by saying, what would happen to the guidelines if we did everything all at once, and then we graphed it? So before we write out the domain and range and all of that, does anybody have any questions with that graph? And I'm going to give you a minute or two because it might take you a while to, if you do have a question, to figure out how you ask it. So no questions? All right, you should be able to, based on that graph now, tell me the domain, range, amplitude, and period. Well, the domain is x is any real number. The range now, the minimum is 2/5, which is less than or equal to y, which is less than or equal to 1, 2, 3, 4, 5, 6, 7, 8/5. The amplitude is 3/5, and the period is 2 pi. Could somebody, before we go on, everybody think of this, when I just say, can somebody, that doesn't let anybody off the hook. I might even call on someone. Can somebody tell me what the only type of transformation is that would change the period? A change in B is correct. A horizontal stretch is correct. And both of those things go, that's like peanut butter and jam. They go together. If I change B to a non-1 number, it will be a horizontal stretch. And that's going to affect how long it takes to repeat. All right, let's take a look now at the next one. Speaking of B, when we take a look at this, B is equal to 1/2, and K is equal to -1/2. By the way, since A is 1, the amplitude is 1. If it has not been stretched vertically, then the amplitude hasn't changed. Incidentally, some of you on your assignment looked at something like this, and you said correctly that this is a horizontal stretch by a factor of 2, but you wrote B equals 2. No, B is 1/2. B is the number in the equation. So here's the best way to do this problem. I draw in my grid lines, my guidelines, for y equals sine of x. And then I move them based on the vertical stretch. So if there was a vertical stretch, then I would move those two lines closer to the x-axis or both further away from the x-axis. But since A is 1, there's no vertical stretch, so that's where the grid lines would be. But now I'm going to move them down 1/2. I don't, you know what? For the time being, just for the next 2 or 3 minutes, whatever happens in between the grid lines, who cares? Just for the time being. Because whatever happens, it's going to move down 1/2 because of the -1/2. So what we're actually doing is we're going to move the grid lines or guidelines down 1/2, And then pretend we didn't move them and graph what the graph would look like. 1/2, 1/2. Now, where's the middle of this? The middle is an important place to be aware of. The middle is here. Which means whatever we draw has to bounce back and forth an equal distance above the middle and an equal distance below the middle. Now, where does sine, this is a sine graph, where does sine normally start? Well, sine normally has a start point in the middle. I would say at the origin, but we've shifted it down so that's no longer the origin. But the sine curve normally starts in the middle and goes up. I'm going to erase this in a second because it's not drawn very well. Now, if it starts in the middle and goes up, will it still start in the middle and go up when a is 1? Yes. There's no vertical reflection. Now what we need to do, though, is look at the fact that there is a horizontal stretch by a factor of 2. Normally the period is 2 pi. What that means is the period now is going to be stretched out and it's going to be 4 pi. If I'm going to go back a number of pages here. If this is y equals sine x, and I stretch it, that means that this point will stay the same, this point will be twice as far away, this point will be twice as far away. It's going to end up looking like this. And then it's going to end up back at the x-axis, stretching horizontally by a factor of 2. It's going to end up back at the x-axis at 4 pi. So now when we sketch this, we are going to start at this red point going up, and we're going to go up, then down, then up, and come back to the middle over 4 pi. So we split this up into 4 equal chunks. And we go up to here, down to here, down to here, up to here. So this is what it looks like. If you wanted to, you could draw in another one on the other side. In terms of domain, domain is still any real number. Range is -3/2 is less than or equal to y, which is less than or equal to 1/2. Be careful here because when you look at those guidelines, don't confuse those with the axis. Don't confuse that middle guideline with the x-axis. It's below. So does anybody have any questions with that example? Let's do a too fast, too slow, just right break. Okay, I think we're okay then. So let's try this one now. I would like everybody to write out, is this F we're on? Let me just check my physical note package and see if I'm missing one. I guess it goes from D to F on yours as well? Yes?
Yes.
Thank you, Aaron. So we're looking at F. I would like everybody to take a minute and write out A, B, H, and K. If you were sitting here saying, what does he mean by A, B, H, and K, then I don't know where you've been in this course. We're talking about transformations here. F is cosine. So you need to figure out what A, B, H, and K are by comparing that function to y equals cosine of x. And Ava, can you type for us, please, what the value of A is? Dan Brienne, can you type what the value of B is? Aidan Crawford, can you type out what the value of H is? And, well, K is obviously -4. I'll do -4. So K is -4. Ava is correct. A is -7. Dan, B is 3. But unfortunately, there we go. Thank you, Aidan. It's 1/3 of pi, not pi, because you have to factor that 3 out. Right? You have to write y equals -7 cosine 3 bracket x minus pi over 3 and then -4. So you have to remember there's that fatal flaw of maybe forgetting to factor the b out. So h is pi over 3 or 1/3 pi. So how do we sketch this? Well, here's how I do it. And you'll want to maybe just put your pen down and listen for a while because things are going to be moving around. The first thing I do is I say that cosine would normally be confined between the upper and lower lines that I've drawn, which are at y equals 1 and y equals -1, and the middle would be the x-axis. But two things happen here. This -7 for A results in a vertical stretch by a factor of 7, which means this distance and this distance are going to be multiplied by 7. The total distance between the top of this graph and the bottom will be 14. Now, I don't have room to move this up to 7, but it doesn't matter. I don't have to. The -4 means I'm going to shift everything down 4 at some point. What does that mean? It means that the middle of the graph, even after the upper and lower lines are stretched, the middle is going to be down, darn it, the middle is going to be down at -4. Now, if it's stretched vertically by a factor of 7, that means the amplitude will be 7. So it's going to go 7 below -4, and it's going to go 7 above -4. So the placement of those 3 lines, which really help me visualize what's going on, are determined by looking at A and K. Now, it is cosine. So if you look at your screen, cosine normally has a start point at the top and it heads down. But since A is negative, there is a vertical reflection, which means that the start point would normally now be at the bottom going up. Except, and this is where things get muddy, that h is pi over 3, and that means that things are shifted to the right, pi over 3, and what that means is the start point is not here going up, it's here going up. Looking on the x-axis, this is 0, pi over 3, 2 pi over 3, pi. So again, following this in sequence, cosine would normally start here and go down. Since A is negative, it's going to start at the bottom going up. But since h is pi over 3, it starts at the bottom going up, pi over 3 to the right of that point. And this, give me 1 second. The identification of this piece of information is crucial to graphing it. Now what we have to do from that start point is draw up, up, down, down, but we have to do that in the period. And if the period is normally 2 pi, and b is 3, that means things have been stretched horizontally by a third. The period is going to be 2 pi times a third. It's going to be 2 pi over 3. The amplitude will be 7. The range we can see from the graph is negative 11 to, must be 3. The domain is any real number. So before I sketch this, which might be the hardest thing we've covered so far, I want to know if that makes sense, that if things are stretched horizontally by a third, then the period will be 1/3 multiplied by 2 pi, which is 2 pi over 3. Any questions with that? Okay, so one last thing. This is a long haul we're in here. Rather than thinking of stretches, it will benefit you more to remember that the period will be 2 pi over b. Rather than taking b and flipping it over to get a stretch factor and multiplying that stretch factor by 2 pi, it's easier to just say the period is 2 pi over b. The amplitude, while we're at generalizations, is the absolute value of a. So now let's sketch this. We have to look at 2 pi over 3 as a period. So if you watch your screen carefully, from here to here is 2 pi over 3. It's 2/3 of pi. So the challenge in front of us is to do the following. To draw at that start point that's highlighted, something that goes up, up, down, down, and ends back at the bottom here. It's got to go up and then down over 2 pi over 3. This distance is the period. So we split that up into 4 pieces. It's got to go from here up to the middle in a quarter of the distance, up to the top in the next quarter of the distance, down to the middle in the next quarter, and then down to the bottom in the last quarter. And we don't need to draw 3 or 4 of these cycles. One cycle is good enough. So it will look like this. And believe me, this is where if your other graphs didn't look that great, this one might look even worse, but it's not important. Okay. Any questions with F? So just take a deep breath because we're not done here. We've got a couple more things to talk about. The first one is, and I apologize, I wish everybody did the same thing all the time, but we don't use H and K with sine and cosine. We use C and D. So rather than having A sine of B bracket x minus h n bracket plus k, we have A sine of bracket B bracket x minus c n bracket plus d. You're just going to have to get used to this. And by the way, both of these are on your formula sheet. This is on your formula sheet, and so is this. And what I want to do now is talk about generalizations. I think what I'm about to say is obvious, and I hope it's obvious to you, that the amplitude is always represented by little a. In the last example, Ava told us that little a was -7, and it is. The amplitude is 7. So one of the first things we learn is that, I'm going to go to the next line here. I'm not even going to leave that in there. This is what you're looking at on your handout, basically. Actually, I want to be careful here. Have I got a different thing? No, that's a review for the next day. Okay, so there's a vertical stretch factor of the absolute value of A. Please make a note, and you can actually write this down in your package, that the vertical stretch factor is the amplitude. I think that's an important detail to know. The horizontal stretch factor is 1 over the absolute value of B, but I don't think that's really that important, because I'm going to tell you something about the period in a second here that I see is not in your notes. There's a vertical reflection if A is negative. There's a horizontal reflection if B is negative. This is all not new to you. What is new is this horizontal shift, which is related to H, which we're now calling C. It has a special word or phrase or name. It's no longer called a horizontal translation. It's called a phase shift. And K, which now has become D, is no longer called a vertical translation. It's called a vertical displacement. We obviously do them in the same order we did before. But, and I'm sorry, I'm really puzzled as to why I didn't put the following information in your notes. So you've already written down, I hope, that the amplitude is the absolute value of A, but you can also write down that the period is 2 pi over the absolute value of B. That little formula that I just wrote with the period is your way of bypassing all the stretches. You don't need to think of stretches to determine the period. Incidentally, and we're going to get some practice with this with an assignment you're going to get shortly, probably later today or tomorrow. If period equals 2 pi over B, then B is 2 pi over the period. If you were to cross multiply K over 1 equals 2 pi over B, you'd get K times B equals 2 pi. And if you divided both sides by K, you would get B equals 2 pi over K. So not only is the period 2 pi divided by the parameter B, the parameter B is 2 pi divided by the period. Now, does anybody have any questions with what's written in red on the board? Okay, this is a long one. We've been going at it for an hour and a half. So I'm going to power through. There's a reason why we're only doing one of these lessons today. We've got a couple more examples to do here. Number 2, we want to determine the equation of this function. This is very close to the question you're going to get on a written response assignment. So I'm going to draw in a couple of grid lines, and we're going to tackle this together slowly. I want everybody to figure out give me a second. There we go. I would like everybody to figure out that if the bottom line is at -7 and the top line is at +7, where is the middle in terms of y? And you can start typing answers when you figured out where the middle is. Is it at y equals 1, at y equals 2, at y equals -1? It is, in fact, at y equals 0. Since the middle of the graph is at y equals 0, everybody, D is equal to 0. There is no vertical displacement. None. If there were a vertical displacement, then that middle would have been shifted up. I would like everybody to figure out what the value of A is for this graph. Aiden says 7, Amy says 7. Definitely, A can be the amplitude. Now I say can be the amplitude because it could be -7. But we're going to go with 7, at least for the time being. So A is 7. Now we're asked to come up with an equation of the form A cos of bx. So let's figure out what B is. B is 2 pi over the period. That's the rule that I just taught you. If you look at the x-coordinate here, it's 12. The x-coordinate here is 18. And from 12 to 18, it goes up, up. It only has 2 of the 4 pieces for a full period. And that distance is 6. Which means that the period must be twice as great, so the period is 12. Because it has to go down, down again. That means we can figure out what B is by taking 2 pi over 12, which means B is pi over 6. Because we can reduce the 2 and the 12. Now we have to make sure this is correct. Well, maybe I'll ask this. How many of you see that we've got a mistake on the board? This will not give us the right graph. It is -7. Because what you do now, that's right, Aaron, what you do now is you start at the top where cosine starts, and then it would go down and down and up and up. But this graph starts at the bottom, which means that A is actually -7. So the equation of this function is y equals A, which is -7, cosine of B times x. And there's no shifts involved with this question. Any questions with that one?
I have a question.
Go ahead, Aiden.
So, because it was a negative and it's flipped, if we put it as a positive and then gave it a C value of 6, would it still work?
Yes. And you're giving it a C value of 6 because this is going to be important for the next one. With a +7, it starts here and goes down. But this graph is up here going down, and you're saying 6 because from there to there is 6. Yes, it would be the same graph. So if you graphed it on your graphing calculator with your equation with +7, and then in brackets you would have x minus 6, it would be the same graph as what we're looking at. But in this question, you were told that's the equation. It wouldn't be wrong, but it would be wrong for this question.
Okay.
Did I answer it?
Yeah.
Okay. Any other questions with this one? I apologize for the length of time this is taking, but I mean, I really believe that it's a long lesson anyway, and we're dealing with a long distance type of learning here, which makes it more difficult. Okay, so now the next question is, I'm going to skip over that question. We're going to do the final question, which is question 4. We've done enough graphing. We have to come up with the equation of this graph. It says write an equation of the form y equals a sine b bracket x minus c plus d. I'm going to give you a few minutes here. I want everybody to see if you can figure out, looking at the graph, what the value of a is. By the way, you're told a is positive, so you can't use a negative. what the value of B is and what the value of D is, but don't worry about C. As you're thinking about that, I'm going to be putting some visual hints up here. Let's see. Jenna, I'm going to ask you to let us know what the value of A is. Katrina, I want to see if you can figure out for me what the value of B is. And Patrick, I would like you to tell me the value of D. And when those three people have the answers, they can go ahead and type them. And, B is particularly tough, but Patrick says D is 1, and Patrick, that is correct. While everybody else is still thinking, Patrick, I know you're typing and not speaking, but can you try to type out a reason why you know D is 1, which it is? A is 6. So you're looking here, Jenna, at the total distance between the top and the bottom. And that total distance is 6. But the only thing we have to add to that is that the amplitude is the distance from the middle to the top or the middle to the bottom. So we don't count the whole distance because there's a vertical stretch. And I have a feeling what you're doing when you said 6 is the amplitude's normally 1, but this thing is 6 times as tall. The amplitude is normally 1, but that means the whole thing is normally 2 tall. Sine normally goes from -1 to 1, which is a distance of 2. So the amplitude, which is A, is actually 3. So we just have to remember to divide that distance that you have in your head, that total vertical distance, by 2. Does that make sense, Jenna?
Yes, it does.
Good. Oh, and that's really a nice layer on top of this, Patrick. The middle of the top and the bottom is at 1. That's why D is 1. That's a perfect way to put it. I can't really think of a better way to put why D is 1. When you take a look at where the top is, which is at 4, and the bottom is at -2, the middle of that occurs at y equals 1. So, Katrina, how are you doing with finding the value of B, which, I'm sorry, I saddled you with the most difficult task here. While you're continuing to think of it, yeah, and it's difficult. What you have to do is remember that B is 2 pi over the period. That's what we need to do. And now we have to look at the period. This is not easy. We have to look at the period, which is the horizontal distance from the beginning to the end of one cycle. And this distance, this period, is 2 pi over 3. So what I'm going to do is take 2 pi over 3 and put it in for the period. So we have b equals 2 pi over 2 pi over 3. And this over 3 is really the problem here. We don't like complex fractions. So what we're going to do here is multiply the top of this and the bottom of it by 3 so that those 3's cancel. And the 2 pi's cancel, we're left with b equals 3. Sometimes this is a little frustrating for me because I'm changing my schedule all the time. I think what I want to do here is finish this lesson and have at least the first part of tomorrow to work on and go over questions. I don't think it's going to be of any value to rush through, assign everything, and then tomorrow move on. Okay, so again, just me reassuring you, don't worry about time. We'll figure it out, okay? So are we okay with everybody that A is 3 and D is 1? Those are the two big ones. We okay with that? Any questions with those? Are we okay with my explanation of how I found B? I look at the graph to determine the period, and I put the period into that formula, 2 pi over k equals b. Any questions with getting b equals 3? Okay, and normally when I ask a student or a group of students to find b, nobody can find it. It's very rare that somebody is able to find it without me showing. So now comes not the toughest one, but the one that people seem to struggle with. What is the value of c? So here's what we're going to do. We're going to do exactly what we did before. I am going to start sketching the graph. Sine, which is what we're after, normally starts in the middle, correct? I don't know why I'm saying correct. I can't see your faces. Sine normally starts in the middle and goes up. That blue graph would have a c value of 0, but it wouldn't give us the graph we want. So the question is, how much do I have to shift that blue graph to make it match the graph we're after? And the answer is, I need to shift it this much, if you look at your screen. I need to take this point and shift it over to here, and then it would match. So how much do I need to shift it? Well, I need to shift it whatever this little distance is. And if this is pi, there's 1, 2, 3, 4, 5, 6 marks in there. That means I need to shift it pi over 6 to the right. I'm going to repeat that. Based on everything we've done so far, if there was no c, the graph would start in the middle where that blue dot is and go up. But the graph we want starts here and goes up. So how can we shift the blue graph to match the red graph? We throw in pi over 6 for c. What that means, everybody, is that the following is the equation. Y equals a multiplied by sine of b bracket x minus c n bracket m bracket plus d. So any questions with any of those parameters? All right, let's try the final one now. What if it's the same graph, but we want it to be cosine? Well, the fact of the matter is the amplitude would still be 3. I want everybody to mull that over. Whether it's sine or cosine, the amplitude is going to be 3, which means A is 3. B is still going to be 3 because B is still 2 pi over the period, and the period is the same regardless of whether we use sine or cosine. D is still going to be 1 for the reason that Patrick said. The middle of the top of 4 and the bottom of -2 is 1. Now, how do we find C? Well, this is what you do. You say to yourself that if C was 0, then cosine would start at the bottom and go down. We want this graph to start here and go down. So how much do we have to shift the blue graph to get the red graph? Well, this time we have to shift it 2 pi over 6, or pi over 3. 1 pi over 3, 2 pi over 3, 3 pi over 3. So we have to shift it pi over 3 to the right, which means we can use pi over 3 for C. That means the equation of our graph, if we use cosine, is y equals 3, which is A, cosine bracket B, which is 3, x minus C, which is pi over 3, n bracket plus D, which is 1. Any questions with that last example? All right, I have a question for you then. Is there a way, I'm going to clone this page and imagine it's a different question. That way I don't lose the first page. Is there a way that I could have 0 for C? Is there a way that I could come up with an equation for this function but use C equals 0? Yes, there is. Can you tell me what that would be, Aiden?
Would you have a negative A and 3 pi, or 3 for B?
Yeah, it would be exactly the same, except I would have to have a negative in front of the 3, because then, see, I'm trying to get that blue graph to match the red graph, but the red graph is also here, isn't it? So instead of shifting the blue graph, when I say blue graph, I mean this. Instead of shifting this to the right, pi over 3, I could reflect it vertically. But the reason we can't do that, which is why I said we're imagining it's a different question, is because you were told A is positive, right? So that's why we're kind of handcuffed in that regard. There are many different ways to get an equation for a function, but you have to read the question carefully so that you don't get an equation that they don't want. Huge amount of stuff to take in, and it turns out a lot more difficult for me to teach when you're not in front of me than I thought it would be. So it took a lot longer than I expected. So the plan is for you in the last at least 10 minutes. I mean, I can't, the class is only officially 2 hours long. I can't just give you 10 minutes and say we're going to move on tomorrow. So in at least the last 10 minutes, once you take a break and stretch and get something to drink or whatever, I want you to get started on these questions. And I will say that for the first, What are we doing tomorrow? I'll let you know by the end, by 2:30, I will let you know what period of time tomorrow we're going to continue to work with this as a group and me go over the questions. So give me just a few minutes. I got to look something up. Get started on these questions. As soon as you have questions, let me know and we'll go over them. And again, you can leave at 2:30. However, I'm here till 3 o'clock. Okay, so give me a couple minutes. Sarah, I will tell you the same thing. We'll do the same thing with tangent that we did in Q1 with this course. I'm not going to worry about tangent even tomorrow. We will probably review tangent at the end of the quarter. Whatever our review looks like, I will review it then. It's that unimportant. It's something you need to know for a diploma exam, but it's not really, really important. Are you satisfied with that? You're welcome.